DevOps augments the traditional software development cycle. It does not replace it. By augmenting traditional software tasks with the collaboration that DevOps provides, problems that exist in a non-DevOps environment can be addressed. The main issue in a non-DevOps environment is the lack of collaboration. When groups operate in silos, they have little knowledge in how their work impacts other teams. Also, teams working in a silo have little knowledge on what other teams actually do. This lack of collaboration has obvious drawbacks, such as the lack of flow of ideas and innovations. There are some other drawbacks in a non-collaborative environment that are more concrete and easy to identify. Collaboration between functional designers and developer reduce software development time. Using DevOps between these two groups will result in better understanding on what the software application should do. In a non-DevOps environment, the functional designers have requirement meetings with the users to determine what a software application should do. Developers take this design and code an application. The developers have no real idea on the value of the application has to the end user or the organization as a whole. The functional designer has little understanding in how an application is actually developed. Using DevOps, the coders can attend design meetings, and the functional designers can attend development meetings. Both teams learn about each other's role in the software development cycle. DevOps between developers and quality assurance testers increase software quality and reduce the testing time. In a traditional scenario, coders don't know how an application is to be tested, and testers have little idea of the features coded into an application. Collaboration here is more valuable than just sharing job knowledge. If the developers knew how the application would be tested, they may employ a testing tool to assist in finding bugs. In addition to collaboration, DevOps is about tools and technology. In a DevOps approach, developers collaborate with the quality assurance testers and determine the testing process and which portions of the testing can be automated. In this fashion, the application has already been pre-tested when it's passed from development to quality assurance. DevOps between quality assurance and operations can prevent deployment showstoppers. After an application has passed the quality assurance stage, it is passed on to operations to be installed. Many organizations have different environments for application testing and application deployment. An application may be tested on a Windows 32-bit machine, but may be deployed on a Windows 64 box. This has some obvious risks. Using DevOps, the quality assurance team can work with the operations group to ensure that the application is tested on the same platform it will be installed on, or perhaps on virtual machines that will duplicate the production environment. DevOps combines knowledge and technology to mitigate any platform issues. DevOps between development and operations improves the consistency of application behavior. Bugs may be reported on a production system that can't be reproduced by a developer on a local machine. As applications have evolved, so have their dependencies. Applications are no longer standalone. Most are distributed and are heavily dependent on the platform and the operating system. Most web applications are also heavily dependent on plugins and even the version of the operating system and the runtime environment. This complex mix of technology makes it difficult to debug issues. In some cases, the runtime environment is so different than the development machine, bugs can't be duplicated at all. DevOps helps with this by supplying tools that emulate production environments.